right. It's a Nian. Cool. So we have all our speakers. So thank you guys for sticking around and coming for this opportunity to have all of us to chat together. So let's start with one of the questions we've gotten from the audience, which I found really interesting. So Fahad was asking, hey, you guys talk about CPU intensive versus memory intensive, but there's more to it than that, right? So especially now in the new world, we have CPU cores. So are there any practices that you guys will recommend when it comes to multi-threaded versus and multi-core environments?
So I can give my point of view, and I hope the other guys will also be able to give theirs. So for multi-threaded, multi-core environment, development of correct software on multi-threaded, it's more complicated than it's on single-threaded. The bugs are much more difficult to track. You have deadlocks, live locks, and so on. And my general impression is that if you have a performance critical piece of code and you focus on the right things, often you can get the performance you want on a single core. Now, as far as the best practices is, just use the libraries that are available to you that support parallelism. We have support in C++ for parallel STL algorithms. There are also other libraries that work with multi-threading and multi-core, and try to do it yourself, thus avoiding the multi-core and multi-threading altogether. Although that's not sometimes possible.
Other perspectives?
I think here it also depends on what you are trying to do, right? Like maybe server-side environments are totally different from clients. Like here, I can chat from mobile perspective. For example, on Android or iOS, you cannot kind of escape multi-threaded environments. Just for example, you cannot perform a network request on main thread, right? So you will kind of get your UI completely stuck, and you need to kind of come up with stuff there. Usually, measurements have to be in place, like tracing, the stuff that Yaniv mentioned before in the talk. Actually, probably we didn't get to chat about it, but like being able to measure things, maybe being able to get details of a system that you wouldn't normally, be able to get just looking at an app from outside. Here I'm talking about locks being held, for example, by the VM. Try to see how long work is actually taking, how the correlation is actually happening, and try to optimize flows for what could be a critical path or a critical flow, for example. Assuming you can detect it.
Yaniv, you look like you wanted to say something?
Yeah, I guess, at least on Android, it also very much depends on what are the sort of actions that we want to schedule them very. Also affects the scheduling logic that we apply, so, and the priority of the threads that we use.
Also, network is another important aspect. Like to go back to the question of what could be other things to look at, depending on the system, of course, right? Like if you are heavy on network, you need to kind of optimize for that. You might even use hardware that people don't commonly use. Here I'm thinking about DPUs or GPUs if you're doing heavy UI work. So profiling is always necessary, and eventually maybe being able to do it at scale.
And Nian, do you have anything that you think?
Yeah, I agree with Simone, and profiling is very important, and it's important to measuring if our application, mobile application is fully utilizing the multiple resources. Is it parallelized or perfectly? Is there any bottleneck to block all the other threads? And I think that's first thing we need to figure out.
Okay. Now, since there are no more questions from the audience, I get to ask you guys a question. So, in our February edition of the Perf Summit, when we were having the same panel discussion, we kind of concluded that Perf is not seen as cool. So we don't always get engineers kind of, being super motivated to go and make their apps super performant. And we were saying, let's make Perf cool again. So now we're 6 months on. I'm curious about your guys' perspective. In your respective environments, companies, apps, is Perf a cool thing?
So it really depends where you work, who you work for. So it depends on the domain. Some people find it important, some people don't. Generally, the gaming industry is really interested in performance. High frequency trading industry is really, really interested in performance. I mean, they invest a lot of money in that. Then you have also embedded Internet of Things, embedded people who are interested in enough performance, let's say it like that. But also a curious thing that happened, people who are interested in performance are actually big data centers. And it's really curious because if you get 10% off of on their critical path, you save monthly $10,000 for the electricity bills. So they're also interested in performance. But there are some just regular people. So I talk from the C++ perspective as an application engineer. I'm not talking, many people here are systems engineer. They have already made components and then they need to make them work together fast. I just focus on one application. So C++, the thing that we work with is performance-oriented language. If you want top performance, you want to use C or C++. And if you're okay with just enough performance, I think Java, C#, these memory managed language are much better choice because they decrease the time you need to get to the market.
One thing I may add is that one trend that I really see it as being more and more adopted is the whole reliability kind of trend, and which, for example, includes chaos engineering. So I see lots of organization, even at kind of traditional industries like financial, adopting these kind of frameworks. And most of the times also they are driven by engineers or architects in the race of increasing the reliability of their services. And if we look at chaos engineering, typically as it gets done, it's very close to performance engineering. So it includes things like doing experiments while the system is under stress, being able to understand the root cause and replicate the experiments. So I guess this is a trend that unexpectedly, I would say, at least for me, is actually improving on the market in terms of popularity.
Yeah, I have a point actually on top of that. That's very well said by we have a high trading platforms, and by the time it's a data world in our terminology. So as soon as the smart data is getting deployed on the cloud, and AI and these smart devices are getting interacted, so performance becomes very important perspectives. Like we are dealing with a lot of telemetry and predictive datas which are present on the clouds, and just to simulate those things, it is very important to have a system to be performant. And that's the reason even in our case we usually carry on with the chaos part, as you mentioned. And this is really important criterias which you need to take care for the availability perspective, because SRE, site reliability engineering, which is also very close to performance engineering, the right shift, the monitoring, these aspects. So the availability metrics at various integration points, which is very important. And when we say performance engineering, it plays a big role there. So it's a never-ending thing. Yeah.
So I don't know, Simone, if you want to talk about the perspective of performance and reliability, and how they're almost counter-cyclical, right?
Yeah, actually, I think it's kind of part of, like if I look from a Facebook perspective or product perspective, it's part of the lifetime of a project, right? We really focus, for example, in getting features out, like user features. And then there is the part of adding performance optimizations, both server side and client side. And eventually you end up with things that those are kind of carryover from the past. That could be reliability issues from functional to actually, crashes or things not performing as expected. And it feels to me like it's all part of the package. Maybe there are things that you postpone later because you don't have the human time or the need to actually do it immediately. But then you reach a point where without optimization or without fixing stuff or improving the underlying system, you cannot build either new stuff or continue what you were just doing if you get maybe 100 million users.
Okay. I think we have a follow-up question on the multi-threaded one. Yeah, let's go. So on Android, we have Kotlin coroutines, and Java will hopefully soon have Project Loom threads. Do you think this will make a difference? Go ahead, Nian. I think you're muted.
Oh, sorry. Yeah. From my understanding, I think Kotlin coroutines. Can you hear me?
Yes.
Okay. I think Kotlin coroutines will not make a big difference because it still need to create a physical thread for the routine, right? So for multi-threading, it can improve the multi-threading issues. But for the Java Loom threads, right? The Loom threads will isolate the thread creating in Java. It will not call a system thread create API to get a physical thread. It just it hide the implementations. So maybe we can reuse the physical threads a lot. So the multi-threading issue, like short lifetime threads, will be solved by the Loom. I think. Yeah, I'm very positive on the Loom project.
Anybody else has a perspective that they want to share?
Yeah, the other kind of approach that is actually also used, I see it used on some high performance databases like ShillaDB, is the kind of C-star framework where you have those thread in a way bounded to their CPU cores. So a kind of a sync architecture where you won't have those scheduling issues anymore, hopefully, but you will have a kind of architecture that maps closely to the underlying hardware infrastructure with benefits such as reduced CPU migration and context switches, etc. It's kind of different, but it's another, in a way, trend that I see also on the multi-core, multi-threaded kind of topic.
Thank you. No location. So I guess maybe to in ending, why don't we do a roundtable and kind of say like, hey, what is the thing that's top of mind for you in the next month or so? What is the biggest challenge you'll work on in the next month? All right, I'm gonna do this clockwise. So Stefano,
I'm the first one. Well, actually, we will be continue working a lot on optimizing performance on Kubernetes, like along the lines of what I showed today, because actually we really think that it's an interesting area where, again, Kubernetes is becoming the kind of operating system for cloud-native applications. So there's lots and lots of configuration aspects that can be automated and that are actually hurting teams today. So my focus will be on, among the other stuff, to continue working on this topic to leverage those kind of opportunities that we have there.
Thank you. Ivica?
I work for Apentra, and we're building it's a tool called Parallel Analyzer, and it's used. You can use it to automatically parallelize parts of the codes or to offload it to processing on the accelerators on the GPUs. So this thing is now slowly becoming ready to becoming ready to hit the shelves to become part in the market. So the tool itself helps regular developers who are not that well acquainted with write performance software by giving them advice or doing some things but doing some things instead of them. So we are planning to continue development of this tool and make it usable, feature rich, and helpful for the developers, so they can get the performance they need. So this is our goal for the next few months and in the future. So we're going to deliver this tool that's performance for the masses.
Yeah, I like it. I think that's a thread amongst some of the stories I've seen today. Is exactly how do we make performance more accessible to
regular people. Yes,
regular people. Yeah, exactly. This is really cool. Thank you, Nian.
Yeah. For me, I think the nearest challenge is the device diversity, like the talk that shows how Facebook Lite is optimized for devices 10 years ago. I think for us, we're also working on many device-specific issues, and we are also trying our best to make the consistency experience for our users across the world. While the hardware capability of the devices are quite different. Like users did edit video on devices 10 years ago and requires good quality. And yeah, I think these are quite big changes for our product like TikTok, right? For near future, I think we may need to care about the performance on different kinds of devices with different screens, maybe a round screen or or TV. So and different operating systems and chipsets, and even different kinds of devices like vehicle or VR devices, AR devices, or some other LT devices. I think some of maybe we should also care the performance on these kind of devices.
This is really amazing, because when you think about the diversity and the explosion in the problem space, and I'm going back to my question to Stefano, I think humans still have job security in performance space for a while.
I agree.
Yeah.
That's really cool. Thank you, Nian. Raman, what about you, man?
Yeah. Thank you. I was on mute. Actually, for me, if you ask me, I'm very curious to understand, the non-functional requirements for the, high concurrency platforms, which are the future. One of the example is connected vehicle platform itself. And of course the blockchain and the machine learning, all these platforms, they are very, how we need to take out the use cases from the non-functional requirement perspective. That is one of my my exploration for the future I'm looking for. And of course the simulation, because as Stefano also mentioned, like we have Kubernetes, now it started that Kubernetes pods execution, even your test framework, the simulation framework from where you are doing the execution of high concurrency load on the system, that also needs to be spawned, and the configuration parameters should be should be mapped with the actual application cluster parameters. So from that angle, I am always curious to create the new use cases in terms of non-functional requirements. And when I say blockchain, this is again a high trading platform, and how we need to take out the use cases for creating the mass and of course the trend, because I always believe on graphs which we get in terms of the actual production volumetrics from the existing system itself, and then I just take the trends out of that, and then based on that I do the predictive workload modeling, is what I feel. And we need to align our engineering, chaos engineering, or performance engineering, all these just the counterpart of each other, and then these things should be having those use cases so that we can do the real-time simulation, and we'll have the less business losses. I know a couple of use cases, the real-time use cases where the big high streaming platform where they have lost the business because of the performance issues. So this will be the use cases are very important, and there should be a central platform where we have all those use cases present. Because for the chaos engineering as well, we have various experiments we do, and they all are independent use cases itself, and you need to simulate in one or the other way the kind of data you are using and your platform is using. So that's what my exploration for the future. Yeah.
Wow, it's really cool. So you're basically trying to come up with a non-functional requirement. Is basically performance, reliability, things that are not, there's no PM guarding that, and you're trying to kind of come up with a B, C, D, all the way to Z of everything that people should keep in mind. That's very cool. And honestly, that should be something you should be sharing. You shouldn't hold it just to yourself. Simo, what's top of mind for you?
Okay, mine, it goes back kind of to the core routines and what we were saying about threads before. For other people that don't know about this stuff, I'm kind of passionate about async code, threading, and all this stuff. And I've been working around the area for quite a few years now, and with the intent to democratize some of the issues that actually can happen at a bigger scale. So at Facebook, we have many framework engineers and product engineers contributing to the same user experiences. And one of the big issues that we have is actually being able to tell people when things go wrong and where they go wrong. And that's an area of investment. Going back to the Kotlin stuff and eventually even Swift, is trying to understand how to get data in those languages, because we don't have yet a solution. And this is a bit of an implementation detail. But the main idea is essentially trying to gather as much data as we can so it can be used by people that are not expert in the domain, and at least take some high-level conclusion of what's going on in a system.
It's really cool. And Yaniv, we finally got to the center.
Yeah. For me specifically, like we mentioned, we are trying to move on Facebook Lite. We are trying to move some of the work that the server currently does to the client side to make it more interactive. So we are trying to add more types of metrics and collecting more profiles from different types of interactions that we currently don't cover. For example, different types of that happen inside the app, either on the UI thread or other types of threads that are actually affecting the user's experience performance-wise. So the first step currently is to try and instrument more types of interactions, and then to guide them.
Thank you so much. All right. Well, I think, let me check. No new questions. I wanted to take the time to thank you all again for having prepared for this summit, taking the time to come here and talk to us, answer to our questions, provide your insights. Also, a big shout out to Alison, who valiantly made this work as flawlessly as we could. Again, Yaniv and Simo, I'm really sorry about the video incident. I also wanted to thank the audience for engaging, all the questions that came our way. And I wish you all a great rest of the day. Performance Summit continues tomorrow. Tomorrow we're more on a US-friendly time zone, so we'll start in the afternoon, but you guys are welcome to come. Thank you again.
Thank you very much.
Thank you.
Thank you.
Have a good day.
Bye-bye.